Do you still remember how to reason by cause and effect? To develop causal reasoning, we propose a thesis and then support it with a cause and effect relationship. Recall this example. It's an argument supported by a causal relationship. The author analyzes the bad effects of taking performance enhancement drugs to propose that it should not be encouraged. It's not difficult to realize that the key of evaluating such kind of arguments lies in the truthfulness of the cause and effect relationship. If this assumed causal relation indeed exists, then the argument can be a strong one. Otherwise, the argument collapses. How do we decide if a causal relationship exists? There are three main criteria for causal relationships. First, the two events must be correlated. Second, the cause takes place before the effect. And third, the effect cannot be explained by a third event. Let's look at the first criteria. The cause event and the effect event must be correlated. Let me tell you a story first. Decades ago, scientists first observed that there were a number of cases of heart disease where coincidentally the person was a smoker. Further systematic research showed a strong positive correlation between smoking and heart disease. Scientists hypothesized that perhaps smoking was a contributing factor. However, before making a defensible argument that quitting smoking would reduce a person's chances of heart disease, researchers had to explain scientifically how smoking caused heart disease. Researchers demonstrated scientifically that nicotine constricts blood vessels in the heart, which reduces blood flow to the heart muscle, thus causing heart attacks. This story tells us what coincidence is, what correlation is, and what causation is. At first, we may observe two events and think that their occurrence is a chance coincidence. Then, as more data are systematically gathered and analyzed, we may discover that the two events are statistically correlated. And with further experimental investigation, we may learn that, in fact, what had at first seemed like only a coincidence actually occurs because of important causal factors. When and if we reach that stage, we will have generated a causal explanation. If two events are suspected to have a causal relationship, they must at least be correlated. Recall the story I told you just now. Before scientists established the causal relationship between smoking and heart disease, they first found some sort of connection between smoking and heart disease. That's correlation. But the risk is some authors may mistake correlation for causation. Correlation is a mutual relationship or connection between two or more things. It occurs when two things tend to happen together. When someone says that A and B are correlated, that means there is some kind of connection between A and B. Perhaps someone who conducted data analysis found that when A was high, B was also high. But note that establishing correlations does not say anything about causation. Causation refers to a specific kind of relationship in which one thing causes another thing to happen. Here's an example. This argument is based on the assumed causal relationship between regular attendance and high grades. But is this real causation or just correlation? Have you thought that it's also possible that students who have high grades tend to attend classes more regularly? In this case, can we say high grades cause frequent attendance? We can't. Then we can't say regular attendance causes high grades either. Here, attendance and grades are simply correlated. If we need to establish their causal relationship, we need additional evidence.